Hello and welcome to another episode here in the theoretical part of the texture series, and I want to go today to color temperature and with a very specific weight on mixed color temperatures, and that is of course very painful when you have to deal with something like that. Kelvin. First, let's clear the term. It's Baron Kelvin, and he was of course a scientist long time ago. He saw the need that we have between Celsius and Fahrenheit another option that is called Kelvin. Just a K, no dot here. When you see a dot, someone has not made his homework. And the relation between these two guys is when you have the absolute 0 point, which is called absolute point because nothing can be colder on this planet here. And this is negative 273.16 degrees Celsius. Or if we express this in Fahrenheit, it's 459.67 degree Fahrenheit. And this is just 0 Kelvin. Just like that. So for science purposes, this was the much easier way to think about. When it can't get colder, it's 0, and from there we have only plus values. Having said that, we have a temperature here. And the idea to use Kelvin for color temperatures was given just by using a little material, a black body. And you can, of course, read more about this in Wikipedia or in your dictionary. But the idea was to have a black body, and when it's 0 degree Kelvin, it's just black and has nothing else to do. Nothing rays out from it. So then we heat this poor little thing up, and then it starts to ray little light out. And this is when it starts to glow, for example, red, orange, yellow, and so on. And this color that we can see with our eyes is then exactly connected to the temperature that this black body had. So we start out with black, and then it starts a little bit reddish. Then it goes maybe to orange, to yellow, and so on. And it gets hotter and hotter, and on the end it reaches blue and bluish white, if you like so. And this is pretty much the range of colors that we have for our photography as well, because it's reproducible, and everything that is reproducible is good for science. That's pretty much in a nutshell, or the rule of thumb for that. So having said that, let's have a look what we do with it. I have introduced already the chromaticity diagram, so I will not do this again. And what I want to do here today is, of course, to talk about this curve here. And this curve is very specific to our discussion here today. It is pretty much the Kelvin curve. And it starts here roughly, and you might correct me, with 1500 Kelvin. And we have here in this area roughly 10,000 Kelvin. And on this point here we have, and I say not a number, we have something that is daylightish. So very blurry, but just to give you an orientation where we are with these values. And when we do a white balance, then we move pretty much everything back and forth here on this curve, and everything else has to follow. So the more far off you are, the more you have maybe problems to get everything back into tune to that, because you limit everything. As we have discussed this already in the white balance tutorial series, I don't want to go there further. But what I want to do here today is, of course, to talk about mixed color temperatures. And that means we have two values here on that curve, and where to go. We can't just say we go in the middle, because the problem is often not that simple. If we had two light sources from the same position going to an object, then this would work, of course, to a certain degree, because the lights could have different values and so on. But what is more important is that when we have an object here, and I say we have a sphere here, we have a little contact shadow just to make the point here, and then we have here maybe the sun, and this should be representing now daylight. And this is of course just a very blurry term. Daylight temperature is not daylight temperature, even if we like so. Some people think it's 5,600, some people are really fixed in the idea it's 6,500, and it changes. And even if the sky goes really dark, it goes down to maybe 2,800 or something like that. Anyway, it's not so important what the real value is here. It is different to a light bulb, for example, most of the time, of course. And when we have here a wire inside that starts to glow, then we are back to something similar to the black body. So these two light sources here illuminate now my object that I have. And that could happen when the sun goes maybe down and the street lights goes on, and maybe I have even something different there, something that is not so nice like an incandescent light, something with gas in it that has a very small bandwidth in terms of light. And I go to this a little bit later. So now we have here an orangey light, and maybe we get here in bluish, or even when we have a nice sunset, something very reddish. So most of the time this will not match. And when we have a sphere, we could say, okay, we split this and we correct this side, and then we correct this side, and then we are fine. Most of the time that's not that simple, because we want to have maybe an object that has a lot of details on it. And all these details collect now, of course not really a shadow, because we have from two sides light, hopefully, and then each light source cancels out the shadow but puts its color into this. And this is not a minor mistake, of course. More than often you have those situations inside of a building. And when you want to shoot something, it can happen that the sun comes through the window, then you have incandescent light, and then you have maybe even fluorescent light. And all of that goes to this poor little object that we want to photograph. So where is the light temperature now? That's of course a big question. And what I want to do here is to discuss a little bit what we can do and what we shouldn't do at all, or what has no meaning, and what we can do inside of Cinema 4D and where we have our limitations inside of that. So let's get started. I have done here my best to get here, and you can see the values in this area, to get here a very neutral gray point. If the brightness is now the best, I don't care at the moment. What I'm up to is the right light temperature. And this is here, so far my Cray chart tells me 5850 Kelvin. And of course we have here something that is green and red. And let's flip over to Photoshop again to get this clear. The green and the lilac reddish axis is then this adjustment here. So we have a lot of potential to get really a clean white point, or gray point as I like to say it normally. And these two axes, even if we have a curve here, is exactly what we have in these two sliders, just to give you a little refresher from the white balance series. So with that in mind, we can change now here something, and I want to do only the temperature here at the moment, because that's the main idea here at the time. And when we go here really down, we can see we get a lot of blue. So a low value gives me here a bluish tone. And as I said, the higher the value goes, the more bluish it goes. So is there something wrong with it? When I have a very high number that's really hot, then it gets here really warm. But the black body temperature indicates normally that it gets bluish. Yeah, that's the counterproductive part, or the counterpart in that, because when we have a light temperature that is really low, then the light by itself is very orangey and or reddish, and then the camera has to take the blue tones very intensively in, means it provides more power to it, and then we get a blue picture here. And when we have an image maybe here with nearly 10,000 Kelvin, where the light source is more bluish, like a blue sky, for example, on the pole caps that goes from 10 to 15,000, for example, then the camera says, okay, there's a lot of blue in it, so the result must be brownish, orangey, whatever, and then we get something like this. So it's always the opposite from the light source that we have. I go here back, get my white point, have here exactly the value. And you have seen already what we are doing here. And the idea is, of course, that we go here with a light temperature that gives me then a neutral value when I want to have a reproduction of the color of the objects. And again, I have stressed this in the white balance series, for capturing the mood that we have, like a sunset or a morning or whatever, we are not really focused on a good gray or white balance. For reproductions, like textures, we are very eager to get this point very, very close and to have a nice stream, a linear way of laying out our gray values. So we get everything as the reality has it, not as our eyes see it. Always the big difference in it. And normally, some people might think, okay, we want to set up the whole scene in Cinema 4D, maybe as 4457 or something like that. And then we adjust our pictures, of course, to that, so everything fits. No, that's wrong, and I will show you that, of course. It's one of the things where everyone knows we check out these pictures as neutral as possible, and then we give that to Cinema 4D. And inside of Cinema 4D, if we need to work with a color temperature, this is then a new start point. And let's hop over to Cinema 4D for that. I start here with this image again, and as you can see, I have here some keyframes already. What I have done here is I have used a camera. I have set up in object here the white balance. I have animated it. As you can see here, it goes from 3200 up to 9000, just for the fun. And I have set here on this keyframe exactly the white balance of this image here. And we have then a light source, which I have connected as well with the color temperature, with the idea if the camera is set up to the same color temperature than the light source, I should get always the same result here, because the idea is when the camera is set to the same color temperature than the light, then it should be always the same. And then we have here the plane, and I have created here a little sphere that we can use later on to just check the parts in it. And of course, I have rendered this for you, and let's have a look to that. So as we can see here, this looks relatively gray, and with the eyedropper, just Control or Command key down, we get here in this area the values. That looks fairly good. Not absolutely correct, so I have used here the gray ball with just gray material. We can check that, of course. This looks perfect here on 65. Let's have a look when I say we had here the 5850, which is very close, so I do not expect a lot of change here. But when we take a look, the values are not the same anymore, so we don't have a gray value here. Let's go a little bit down, just to check what we get, and it's much warmer here already, and we have a little difference here inside, not so much, but we can see we go here really into an area that looks like a warmish gray, and it's not so stable. There's not a big difference, but we get here already the impression something has changed. And we have to take a look here to this histogram. The blue area here is much more on the left side, and when we change this, we get here everything a little bit more on top of each other, which indicates when everything is on top of each other in an RGB histogram, then we have, of course, a gray value. And here we have the color checkers, but everything else, the gray, the dark here, and these are all on top of each other, the main area. That's why I have used this here, because it's something that we all know. It's relatively neutral, and we see how it moves here. This might not really answer everything, but the first thing that I want to nail down is Cinema 4D, if not adjusted at all, 6500 is perhaps the best guess to get neutral white images. If you do not prefer to go in any direction, this would be my best guess here. And when you take a look here, when you go to the camera, you have here in the white balance a little preview, and the daylight is already here, 6500, and flash is a little bit warmer, fluorescent, and so on. It goes really down, and it's not only Kelvin, and I will explain this, of course. I want to go into another example. In this scene I have used 4 different images. One time the image that is, from my point of view, nicely balanced, so we get a clear gray tone here, and then we have one with 2500 Kelvin, 5000 Kelvin, and 7500 Kelvin. So as I have explained this was in a much warmer light as supposed to be, but it was of course all in the same light, but adjusted differently in Lightroom. This is 5000 Kelvin, so it is a little bit different, a little bit cooler than the 5850. And here we have 7500, as I said, very warm. So what we need here is, of course, now something that gives us an idea what we are doing. When we put now everything to 2500, and the theory would be correct that an image that we had in Lightroom shot at 5850, then down corrected to 2500 would be correct, is then just wrong, because it's just bluish and you can see nothing works here. So another proof, we have to put the right material in neutral. Otherwise we get here very weird colors, and we see already the yellow is gone here, and the reddish is here nearly not visible at all. That's not nice. And now let's go to the opposite direction. And you can follow here with the white balance 7500. This looks warm here, it's not neutral. This looks here now a little bit more correct, but the whole idea is, of course, we want to have material that we can stick in to a scene, and we don't have to worry anymore if we had adjusted this right. So if anyone had the idea to go with the color temperature that we want to have in our target scene here, then adjust it right here in Lightroom with this slider. That's not the way it should be. Neutral, and then go with neutral material into Cinema 4D. Just to sum it up and to come finally to our Kelvin demonstration, I have created here 3 light sources. I have explained the situation with the light sources before when we talked about flashlight, and of course, as with the flashlight episode, I avoid here to have any reflections in it or specular highlights or something like that, because first we have to explore the area just based on the light situation, and then we can go into reflections and other problems. The mixed light situation here is of course clear. We have 3 lights, and when I go here to this little triangle, I can twirl out the option to use temperature for this. And I have set here these light sources just randomly. And this is 5500, this is 4785, and 7407. And I have set up the camera here to an animation again. This endpoint here is now 5500. And I can go here then down to something like 6500. So, and lots of steps between, 4785 for example. And that means if you have followed here with the light, each of these keyframes here has one value. And the first one is of course what we consider as daylight. So one light source on 30, the next light source adjusted on the 60, and on frame 90 the last one here 5500. I have rendered this of course to make it fast, and I have done here just in rainbow, one time as luminance and one time as just an diffuse material, just color, nothing else on it. And so we have in the background a Cray material and a normal Cray here on the ball. So let's have a look how that looks, and I have to go here to this preview, and then I get here my picture. Maybe I have to make it smaller. So what I wanted to have here is, of course, first what I get here in terms of situation when I have 6500. As you can see this here on the number. And when I go with the command or control here to this Cray ball, then you can see that these values here are not the same. So I have here to deal with these light sources, and I get all values, but nothing is just Cray. And Cray is, of course, when all three values are the same, then we have Cray. And Cray means here, of course, when we stay in sRGB, in Adobe RGB 1998, or in ProPhoto, where the definition is that when R, G and B is equal, then we have Cray values. So with the light sources here, the 3-point light, not to compare with Hollywood light, then we have different values here. So no luck here, and there's no remedy for an object like this, except we make maybe very sophisticated masks, and then we have for these three light sources, of course, something that helps us. And all these light sources finally gives me here a light that results in something that is equal to the luminance area. And again, luminance by itself takes no light source in. It's just pure the color, like in Photoshop, where we have also no need for a light source. Let's go slowly here to number 30, where we have one light source equal to our camera. And please have always an eye to this histogram here. So let's have a look here, and then we can see this is close to Cray. I would say we have now the position of this light source here in the camera, so that's equal. This is far off, and you can see this here in this area, it's also far off. We can see here that the yellowish tone is much larger now, and the violet or lilac, if you like so, is a little bit pushed in. I move this here again, in and out. You see the change? Now let's go to number 60, which is another light source. Let's check this out. I think here we have our balanced candidate, where the camera has the same light temperature than this light here, but we see here it's much bluer, and here on the floor we have also no luck to have any Cray values. And let's have a look here to these values. That looks relatively equal. It's not so big of a change, and I expected that, but let's go to frame number 90, and we have here a little bit, and we have here a little change. This is, funnily enough, relatively even. So let's take a look here. This is not balanced, this is not balanced, and here we have the same values. So in each time when we go with the same light than the camera, we have the same result. But as you can see, and I will start this engine here so you can see here the change, what happens here to the image. It's pretty radical from my point of view, nothing that you can take easily. And the change here in the light is of course affected from the camera, from this bar, and the lights itself adds here a change as well on it. And when I stop this here, have a look. When I start here with 0 to the histogram, I go now to 30, I go to 60, and I go to 90. Huge changes here. And to balance out this is of course a huge effort. And if it is the whole picture, it's easy. But if you have details, like you can see here, this color is different than here. And when you have a lot of details, this gradient from one side to the other is then per detail. And that's pretty difficult to get out. So I went to Photoshop here, and you might remember these little guys here, where we had natural light with some color casting, 1 flashlight and 2 flashlights. I take this here because these are Cray balls and we have seen them. And so the normal way, if you have already a color cast here, you go here to this filter palette, and sorry that you can't see that. I hope I can move this up. No, the photo filter gives me here now the option to warm it or cool it, which is the technical term for it. CTO, correct to orange, or CTB is normally the way, and 85 or 81 or 80 or 82 would be the right one. So cooling would be this, and warming would be then this way. So what happens if I get an image that is already warm? And warm means here the color temperature. Then I take here just another photo filter, and I go this time then here just with a cooling filter. And is that working really? Let's have a look in the info bar. And when I go here through these areas, you can see first I was not even there, even close, but now I'm even further away, and I have the feeling it's all on the top. Let's have a look without. This looks pretty nice here, 213 to 10 or so. Then I make my first step here, get my first flip, and then again. So it doesn't work. Maybe we could fine-tune this a little bit, but on the end we take color out, we limit it. That means we darken it. We can't just add it, even if there's a preserved luminosity in it. But on the end, we deal with a lot of values here, and we change something around. Let's have a look to that in detail. And when we have a color cast inside of our image, it's sometimes not that simple to get out again. And I have created here a little game just with colors, with gray values, and have an eye on these numbers here. This is all very precise here, so there is no little differentiation or difference to any gray value here. Everything is nice and neat. What we normally do when we have a color cast in it, maybe an incandescent light on it, and we had the camera not really calibrated, then we have here maybe something warmish. And you can see this on the values. The green and the red, which is combined normally yellow, gives me here higher values than the blue. So we could put some blue in it and reduce maybe green and red a little bit to balance out everything, and we get our color back. Or what mostly is done is, of course, to take a color filter here again and take a coolish filter in front of the lens, for example. And then it gets really ugly, because then we have the wrong light, we have something in front of a lens, and on the end we get something distorted, because it's not just a linear way how everything works. Bluish is a different frequency, and reddish is a different one as well. So just to limit everything or to change anything is kind of difficult. It never really creates a good idea. So when we have something like that and we want to see what happens to the poor thing here, then we can take the same picture. And when we don't have this, of course, then we just take here a neutral gray and put it on top, and that value is then for our color card, and we put it to difference. So now we can see here already what is not the same, what has changed. And you can see here some areas are much brighter than other areas. Here we have no change, for example. Here we have a lot of change, here we have a lot of change, and it's difference. That means we see the difference. If you want to see really what happens, then we have to go here to, for example, levels. That works even in 32-bit. And then we have to flip here these two guys to get a negative of the whole picture. And then we can see what happens here finally. And when you want to see a little bit less, then we can see these are all the changes here. Not very nice. Okay, so what is to do when we want to have finally now everything back to normal? Then we could go ahead and say we need here these values, and I magnify now the saturation here, so to say. Then we can see we have to deal now with these values. On top of this, because this is our reference, we put a curve, and as we see here now already what happens, we can say let's pull out a little bit the blue, and we see here in the middle we have already a little bit more success. Now we have too much yellow in it, so a little bit less, and it's very tricky. And then we can go with each channel. And normally what I do is to go ahead and take only a channel here, maybe just green, set here the green, take my hand, and then I go here and try to find the point where we have it exactly. And for that I go normally out of my levels and try to find here the black point each time. So when I have done this here, of course, and normally I go back to something like this, or maybe something like this. And this gives me a nicer view here to the way the difference works. And I have done this here with the curve, of course. So I can see here already I have a little bit problem with the blue, and you will see immediately why. Because the blue is here on top, of course. I can't go higher. And the only way out would be maybe to go here with the blue and move it a little bit to the side, even like the other ones. And then this is out of that as well. But you see here in the colors we have some changes. It's of course now magnified here through the levels. And when I take a look here to our curves here, then we see they are really splitted out and they are not really straight here. When you see here the points, they're going all over the place. It's not a nice game, it's not simple. And that's only based on two little filters. Now think about two colors mixed on the surface, gradually going from one to the other in the shadows, in all over the place, and so on. Let's have a look how it looks now. And this is with the curve, with adjustments, and it looks nearly okay. I have here 1 point difference, I have here 1 point difference, so it looks okay. When I take the curves out, I get my color cast back, and you can see here that works now this way. So we have lost, of course, something on the whole way, and that is then mostly expressed in a shift in the colors. It's not really the same anymore. When I go here just to normal back again, then I can switch, and you see this in the histogram. Maybe not so much in the colors. I see here a shift, and I see shifts here in the bluish. And perhaps my curve is not precise, but normally when you filter stuff out a little bit here, a little bit there, there's always a loss. It's really hard to get this back because these colors have all a different value finally in terms of brightness and how we perceive them. There comes the eye and the subjective back into the game. After a half hour, I know it's a little bit much to take in, but on the end, we know already our pipeline. We shoot with the camera, we bring it into Lightroom or Photoshop, we set a white balance to it, and as we talk about textures, we get then our image, and we don't have to think about this anymore because it's neutralized based on profiles that we have discussed, based on white balance and so on. This can go then into the library in our archive, and we take it to as many projects as we want because it's not limited to one specific mood in the images or so. That's the idea. And when we can draw a clear line and we can say this chapter is done, we don't have to think about anymore, then the next step here with the project is then much simpler because our focus goes then into something completely different. Last but not least, one little tip, and it's maybe not the best idea, but sometimes you can't avoid to have a situation like this with different light sources in. And of course, that only when the light sources all together play nicely and cast no hard shadows into the surfaces, so you have any way to diffuse everything and so on. The idea is to go with the flash situation that we had, but one time you shoot without, one time you shoot with flash, and then you take the colors only from the flash, not the luminance, but the luminance from the situation that you had before. There is of course a problem in it. And you have to be very careful when you have colors or when you have light situations like this. Darkest tone, mid-tone, white or brightest tone. In this area you have the most saturation because the values can go the furthest away from each other. And the more they go to this point, the less saturation they have. So if I have now not enough luminance for my flash, but I have all these color values, maybe I distort here this area a lot. So this needs to be done very carefully. The flash gives only the light, and you have to go maybe into lab mode to do this, or you take the blend modes, for example, luminance and then color. and you mix this then together. That would be the only way where I could think of to live exactly with the light situation that you have, but you use a shortcut to get the luminance from these light sources and the colors then from just a flashlight, where you don't have the need for anything else. It's not the best method, it has limitations and maybe great limitations, but if nothing else helps, that would be my tip here. So thanks for listening, have fun with it, bye bye.